Chapter number 9, Solar Radiation, Heat Balance and Temperature. Solar radiation, heat balance and temperature. So what is wind? Air in motion is called as wind. Second point, Earth is surrounded by air all around. This envelope of air is atmosphere. Next point. So what is atmosphere? Atmosphere is the envelope of atmosphere. Next point, amount of heat received by different parts of the earth is not the same. This variation causes pressure differences in the atmosphere. This pressure difference leads to transfer of heat from one region to the other by winds. Next point, solar radiation, which is also called as insolation. Aphelion occurs on 4th of July. Aphelion is the point when the distance between the earth and the sun is the maximum. So it is on 4th of July. And perihelion on 3rd of January. Perihelion is when the distance between the earth and the sun is the minimum. Next point, factors causing variations in the insolation are: first, rotation of earth on its axis; second, angle of inclination of the sun's rays; third, length of the day; fourth, transparency of atmosphere; fifth, configuration of land in terms of its aspect. Next point, so next, Earth's rotation of Earth on its axis. Earth is 66.5 degree with plane of its orbit around the sun. Earth's axis is 66.5 degree with the plane of its orbit around the sun. Okay, then angle of inclination of the sun's rays is explained here. Higher the latitude, lesser the angle of insolation, resulting in slant sun rays. Slant rays cover more area than vertical rays, therefore the net energy received per unit area decreases. The slant rays to pass through the greater depth of atmosphere, resulting in more absorption, scattering and diffusion. Next point, within the troposphere, water vapor, ozone O3, other gases absorb much of the near infrared radiation. Next point, red color of rising and setting sun and blue sky is due to the effect called as scattering. Next point, maximum insolation at subtropical deserts due to less cloud cover. Maximum insolation at subtropical deserts due to less cloud cover. Next point, equator receives less insolation than the tropics due to the presence of the clouds. Next point, the air in contact with land gets heated slowly and the upper layers also get heated via conduction. Conduction takes place when two bodies of unequal temperature are in contact with one another. Flow of energy from warmer to cooler body takes place in the process of conduction. Next point is convection. In convection, air in contact with earth rises vertically on heating in the form of currents and further transmits the heat of the atmosphere. This process of vertical heating of the atmosphere is called as convection. Convective transfer of energy is confined only to the troposphere. This is important. Convection transfer of energy is confined only to the troposphere. Next point, advection. In advection, heat transfer through horizontal air movement. Horizontal movement is more important than vertical movement in heat transfer. Next point, middle latitudes. Most of diurnal, that is day and night, most of diurnal variation by advection alone. Lu is the outcome of advection process. Okay, so most of the diurnal variation is done by advection alone. Advection alone. Lu is the outcome of advection process. Next point, terrestrial radiation. Terrestrial radiation is in the form of long wave radiation and from below, that is from the surface. Terrestrial radiation indirectly heats the atmosphere. Heat budget. Next point is heat budget. The reflected amount of radiation is called albedo. So what is albedo? Albedo is the reflected amount of radiation from the surface of the earth to the space. 65 units are received from the sun, which is equal to 17 from earth and 48 from atmosphere, which are reflected back, and the left out 35 out of 100, which is not mentioned here. The 35 units are reflected back by the clouds present in the atmosphere and through various gases present in the atmosphere without reaching the earth's surface, and they are reflected back to the space. Next point, there is a surplus of net radiation balance between 40° north and 40° south, and the regions near the poles have a deficit. Heat redistribution takes place from tropics to the polar areas. Next point is temperature. While heat represents the molecular movement of particles comprising a substance, the temperature is the measurement of degree of how hot or cold a thing is. So heat represents the molecular movement of particles comprising of a substance, and the temperature is the movement in degree. Temperature is the measurement in degrees of how hot or cold a thing is. So next point is factors controlling temperature distribution. So the following factors control the temperature distribution. First, latitude. Insolation varies according to the latitude. As we know that the latitude of equator is 0 and the latitude at the poles is 90°. So as we move from 0 to 90, the sun rays become more slant, and this lead to the variation in the insolation, and hence less insolation in polar regions as compared to the tropical regions. Altitude. So another factor controlling temperature distribution is altitude. With every 1000 meter rise, there is 6.5 degree Celsius decrease in temperature in the troposphere. It is called as normal lapse rate. Normal lapse rate. Distance from the sea also affects temperature distribution. Sea breeze and land breeze moderate temperature. So during day, when heat comes from the sun, both sea and the land gets heat, but land heats up more quickly. So the air near the land rises above with convection current, and the high pressure is created in the sea, and the air in the form of wind tends to move from sea to land in the daytime. So it is known as sea breeze, and land breeze happens during the night time, and it is from the land to the sea. Air mass and ocean currents also control temperature distribution. Hot or cold air mass result in hot or cold temperature. Warm or cold current results in warm or cold coast temperature. Now fifth point is temperature distribution. Temperature distribution is shown by isotherms. Isotherms are generally parallel to the latitudes. The deviation is more pronounced in the January. The deviation of the isotherms is more pronounced in the January than in the July, especially in the northern hemisphere. In January, the isotherms deviate to the north over the ocean and to the south in the continents or over the land. Next point. In southern hemisphere, due to oceans, isotherms are more or less parallel to the latitudes, and the variation in temperature is more gradual than in the northern hemisphere. Next point. The highest range of temperature is more than 60 degrees Celsius over the northeast part of the Eurasian continent. This is due to the presence of continentality.